Hello and welcome to your favorite Shridevi classes YouTube channel where we inculcate interest and confidence in science and engineering education. Today in our playlist class 12th physics with subject electrostatics, learn about the concept of potential gradient. The maximum rate of change of potential with respect to displacement is called as potential gradient, and we will relate this concept and we will learn how potential gradient is related to strength of electric field intensity. We'll also solve some very important examination questions related to potential gradient. Let's start. A charge in electrostatic field experience force, and in such force condition displacement of charge involve work done. An amount of work done in moving a unit positive charge from one position to another position in electrostatic field is called as potential difference, and elemental potential difference for elemental displacement is given by this yellow highlight relation, negative dot product of electric field intensity and displacement. Here this negative sign is significant as positive charge experience force in the direction of electric field, and bona fide positive work is done by external agency only when charge is moved against electric field. So this displacement is measured in the opposite direction of electric field, and here dl cos theta is this component of displacement just opposite to electric field, and since this displacement is measured opposite to direction of electric field, a negative sign is used. Now rate of change of potential with respect to displacement is minus e cos theta, and for different values of this theta, angle between opposite direction of electric field and displacement, we have different value of rate of change of potential with respect to displacement, and maximum value of rate of change of potential with respect to displacement is known as potential gradient, and it occurs when this theta is 0 or charge is moved just opposite to the direction of electric field. The magnitude and direction of maximum rate of change in this scalar electric potential function is a vector quantity, and that vector function is known as potential gradient or grade V. Now grade V vector has a direction in which it is occurring. In our case, this direction opposite to just electric field is the direction of grade V or maximum rate of change of potential with respect to displacement, and potential gradient magnitude is equal to magnitude of electric field intensity. So we can say potential gradient and electric field intensity both are vector of इक्वल मैग्नीट्यूड एंड ऑपोजिट डायरेक्शंस। विद्युत क्षेत्र तीव्रता में रखे हुए आवेश पे विद्युत बल अनुभव होते हैं और बल की इन स्थितियों में विस्थापन कार्य की आवश्यकता बनाता है। एकांक धनावेश को विद्युत क्षेत्र में एक स्थान से दूसरे स्थान तक चलाने में किए गए कार्य को विभवांतर कहते हैं, और एक विद्युत क्षेत्र में अल्प विस्थापन में किया गया अल्प एकांक आवेश के कार्य को अल्प विभवांतर कहते हैं, और अल्प विभवांतर को इस पीले हाईलाइट अनुसार विद्युत क्षेत्र तीव्रता और विस्थापन के डॉट प्रोडक्ट का नेगेशन कहते हैं। और यहां जब हमने ऋण चिन्ह लिया है तो विस्थापन का वो घटक उपयोग किया जाता है जो विद्युत बल या विद्युत क्षेत्र की दिशा के ठीक विपरीत दिशा में है, और ये विस्थापन क्योंकि विद्युत क्षेत्र तीव्रता की विपरीत दिशा में देखा गया है तो यहां गणनाओं में ऋण चिन्ह लगाया गया है, और ये इसलिए किया गया है क्योंकि हमें पता है एक धनावेश पर धनात्मक कार्य बाह्य कारक तभी करेगा जब उसे विद्युत बल के विपरीत विस्थापित किया जाए। अगर हम dl का पक्ष रूपांतरण करें तो विभव में दूरी के साथ परिवर्तन की जो दर है वो ग्रीन हाईलाइट अनुसार माइनस ई कॉस थीटा हो गई है, और अलग अलग विस्थापन की इस कोणीय स्थिति के अनुरूप विभव में दूरी के साथ परिवर्तन की दर के अलग अलग मान होंगे। अगर हम एक आवेश को विद्युत क्षेत्र तीव्रता के लंबवत चलाएं, थीटा अगर 90 डिग्री है तो हम देखेंगे कि दूरी के साथ विभव में किसी भी प्रकार के परिवर्तन नहीं होंगे, और विभव में दूरी के साथ अधिकतम धनात्मक परिवर्तन इस थीटा कोण के शून्य मान पर होगा जब हम आवेश को विद्युत क्षेत्र के ठीक विपरीत दिशा में चलाएं, और कॉस 0 1 है तो हम पाते हैं कि विभव में विस्थापन के साथ अधिकतम परिवर्तन की दर विद्युत क्षेत्र तीव्रता का ऋणात्मक मान होगा, और ये आवेश को विद्युत क्षेत्र तीव्रता की ठीक विपरीत दिशा में विस्थापित करते समय थीटा 0 स्थितियों पर प्राप्त होगा। तो हम कह सकते हैं कि जो हमारा अदिश विद्युत विभव का जो फलन है उसमें परिवर्तन की जो अधिकतम दर है दूरी के साथ वो एक सदिश राशि है और इस सदिश राशि को मान और दिशा में हम पोटेंशियल ग्रेडियंट कहते हैं। जो ग्रेड वी या विभव प्रवणता है उसकी दिशा वो दिशा है थीटा इज इक्वल टू 0 वाली, जिसमें विभव में सबसे अधिक दर से धनात्मक परिवर्तन होते हैं और विभव प्रवणता का जो मान है, विभव में दूरी के साथ परिवर्तन की अधिकतम दर, वो विद्युत क्षेत्र तीव्रता के मान के बिल्कुल बराबर है। तो हम कह सकते हैं कि विभव प्रवणता और विद्युत क्षेत्र तीव्रता दोनों बराबर मान के और परस्पर विपरीत दिशा के सदिश हैं। दिस प्रॉब्लम इज वेरी स्ट्रेट फॉरवर्ड। इफ इलेक्ट्रिक फील्ड एट एनी पॉइंट इज 50 न्यूटन per coulomb in plus I direction, then what is potential gradient at that point? So potential gradient is numerically equal to electric field intensity, that is 50 volt per meter. Newton per coulomb and volt per meter is one of the same thing, but the two are in opposite direction. So since electric field in plus I direction, potential gradient is in minus I direction. So when we move in plus I direction, we are moving from high potential to low potential, and for positive change we have to move opposite to it in minus I direction. So potential gradient is 50 volt per meter in minus I direction. This is very good example to illustrate relation between potential gradient and electric field intensity. We have given two potential line V1 and V2. V1 is at higher potential than V2. In the electric field between these two different potentials, we have three different positions X, Y, Z, where we have to find out electric field intensities between two potential lines V2 and V1. At X this red displacement, at Y this magenta displacement, at Z this cyan displacement got identical potential variation, but at X the amount of displacement for same potential difference is least at X position. So X got highest potential gradient or magnitude of electric field and Z got least potential gradient as this displacement is maximum for same potential difference. So at Z least potential gradient means least electric field intensity. So at these three positions X got highest electric field, Y got intermediate magnitude of electric field intensity, and Z got least electric field, and electric field is directed against these arrow positions. These arrow positions are direction of potential gradient, means direction of positive change in potential, and electric field intensity is just negation of it and is directed opposite to these arrows from high potential V1 to low potential V2. Force on unit positive charge is electric field intensity, and amount of work done for elemental displacement with displacement is considered in the opposite direction of electric field. Small amount of elemental work done per unit charge is elemental potential difference and is negation of E dot dl. Now in vector notation, electric field intensity got x component Ex in unit vector I cap direction. Similarly y component Ey got j cap direction and Ez got k cap direction, and elemental displacement got dx component along I direction, dy along z, and dz along unit vector k directions, and the dot product results in Ex and dy displacement are mutually perpendicular. So the dot product of Iz or I dot k is 0. So it is Ex dx only. Similarly Ey with dx displacement got 90 degree angle, and Ey electric field with dz displacement also got 90 degree angle. So these two dot product are 0, and the only work component is Ey dy. Similarly Ez dz, and total amount of work done in elemental displacement is dv given by this dot product results with negation side. Now if displacement is partial only along x direction, dy and dz is 0, then the partial change in potential is only due to electric field along x direction. Similarly for partial displacement only along y direction and no displacement along x or z, the change in potential is contributed by only y component of electric field intensity. Similarly for partial displacement in z direction, the work component involve only z electric field component, and the relation is this. So we can say x component of electric field is partial rate of change of potential with respect to x with negation sign. So potential gradient along x when negated give x component of electric field. Similarly potential gradient along y direction with negative sign gives me y component of electric field, and z component of electric field is related to potential gradient along z direction. So electric field in vector notation can be write as dv by dx along eta direction, dv by dy with j component, and dv by dz with k component. And if v is common and this operator is considered as grade operator shown by this reverse triangle symbol, and negation of grade V is electric field intensity. This numerical example will help us to understand concept of potential gradient and its relation with electric field intensity. We have given a potential function in terms of x, y, z components in this yellow highlight, and we have to find out electric field intensity at coordinate 1, -1, 2. So we know electric field got x component as negation of potential gradient along x direction. When this potential function is differentiated with respect to x, 1 by x got -1 by x square, minus minus become plus 4xy. For this partial change, y and z is treated as constant. So y and 4 are constant and x differentiated with x is 1. So it is with that negative sign -4y. Since for this partial change y is constant, so this third component got 0 rate of change, and for x coordinate 1 and y coordinate -1, the values of x component of electric field is 14 volt per meter in I direction. Similarly, partial rate of change of potential along y direction is potential gradient along y direction, and its negation is electric field component along y direction. And with voltage function, when it is differentiated with respect to y, we keep x and z constant. So first component got no y dependent parameter, so its differential change in its value 10 by x is 0. Similarly, 4xy when differentiated with respect to y results in 4x, and with this negative sign it is -4x. Y square when differentiated with respect to y give me 2y, and 2 3s are 6, it is 6y with negative sign. And for x is equal to 1 and y is equal to -1, the values calculated as 2 volt per meter along y direction. And when potential gradient along z direction is taken, this potential function has no component of z, and for this partial change x and y both are constant, so this constant will not change along z direction. So electric field component along z direction is 0, as potential along z direction remains constant. And it is a universal fact, when potential along certain line is constant, then electric field along that line is 0. So we can say x component of electric field is 14 volt per meter in I cap direction, y component is 2 volt per meter in j cap direction, and there is no z electric field component. We assume that this learning video has explained the concept of potential gradient to such an extent that you can deal with examination questions and can understand its relation with electric field intensity. These learning video will definitely improve your physics conceptual understanding and increase your examination score. Keep watching. We'll meet again with similar informative conceptual learning video. Thank you very much.